All right, back with the dreaded part 3 of a video. Usually we don't get to this, but like I said, this is a fairly long lesson with a bunch of little things. Last example, we saw a case where p at x and q at x had a factor and they canceled, in which case the rational function f at x would have a hole at the value that was both 0 on the top and bottom. But if that doesn't happen and q at x is 0, we get a vertical asymptote. That's the kind of the more regular case. So we've got x at a is a vertical asymptote. What happens to the function to f at x for x near a? Well, there basically are two cases to consider. We could think of f, what happens to f as we get close to the asymptote from the left and also from the right. So it could be that the function goes high like this. So x is getting close to the asymptote from the left, then f at x gets really, really big. Now how we write that is x approaches a from the left. A little minus sign means a little bit lower or a little bit less than a. What happens to f at x? Well, f at x gets really, really big positive. Goes to positive infinity, right? And that's how we would write that. That's the symbols. Now, the other case would be it doesn't go high, that it goes low. And we've seen this already. X gets close to a from the left. F at x goes to negative infinity. Now, in order to consider the behavior near an asymptote, we could also think of x getting close to a from the right, on the right. And so in this case, if I'm thinking of the x getting close to a from the right, it could be high or low again. And let's practice our symbols. X gets close to a from the right. What happens to f at x? F at x gets big positive. And in this case, gets close to a from the right. F at x gets big negative infinity. How do we know which? Well, there's a couple of ways to think of this, and we're going to try and go through them reasonably quickly here. Investigate the behavior. This is exactly. How do we know which? So we know that x equals 3 is a vertical asymptote, but we don't know, right? So this is what we're thinking. We know x equals 3, and you're not writing this down. I'm making a mess here. It's going to be up here or up here, and then on the right, up here or down there. Now the question is, we're going to pick one from this side and one from this side. Which is it? We don't know. Okay. Well, this is how we decide. One would be, well, let's jam some numbers into our calculator. What does it mean to be, on the left? As x approaches 3 on the left. Well, if I think of x getting close to 3 on the left, I might say a little bit less than 3 is maybe 2.9. Well, where's my function value then? I go -4 over 2.9 minus 3 and do that in my calculator, pound that into my calculator, I get 40. Now, if I get a little bit closer, because it's approaching 3, I know it can't be equal to 3, that would be undefined, but if I get a little bit closer to 3, to 3, well, that's 400. Well, what does it look like? As x approaches 3 from the left, a little bit lower, f at x goes to positive infinity. This number is just going to get bigger and bigger and bigger. Now, what about on the right? It's a similar calculation. On the right would be a little bit bigger than 3, 3.1. Do a calculation. 3.1 minus 3, that's going to be -40. What's even closer to 3 but still bigger, 3.01. And again, I could get, as close as I possibly wanted and never quite get there. But I get an idea, right? What's happening here? As x approaches 3 from the right, f at x is going towards negative infinity. This method, by the way, folks, is called the numerical method. Numerical method means, basically clunking a bunch of numbers into your calculator. I'm going to show you a different way, which would be what I like to call the logic way, which is a little bit tougher, but faster. So you wouldn't have to do both ways, by the way, folks. So this idea is, as x approaches x approaches 3 from the left. This is what I think. This is what I'm thinking. F at x, which is negative 4 over x minus 3. So I think of positives and negatives. On the top, I have a negative. And on the bottom, this is a little bit less than 3. 2.9-ish, a little bit less than 3. So what do I have? I have a teeny little small negative, because this is 2.9. This is a tiny small negative, right? And when I divide by a tiny number, it gets big, right? So I get a negative divided by a teeny negative. A negative divided by a negative is a positive, right? Or I think of this as a big positive, right? That's why I wrote it big. And this is all I think this. And so f at x goes to positive infinity. And similarly on the right, I'm thinking here of this function. Still, on the top I have a negative, negative 4. But then this number is a little bit bigger than 3. So what do I have? A number that's a little bit bigger than 3, subtract 3. That means that's a teeny positive. Teeny weeny positive. And I have a negative divided by a positive, and divided by a teeny weeny number is going to be a big negative divided by a big negative, right? Big negative. So then I can logically think f at x goes to negative infinity. And notice it's very similar, except for I'm not relying on my calculator there. I'm trying to use my head and think about the numbers. To investigate a vertical asymptote, we must consider behavior on both sides. Okay, now notice this. On this picture, what this tells us now, I know I've got my 3 here, and I know when x is on the left, it goes positive infinity, like this. When x is on the right, negative infinity, like that. That's a pretty good picture. I don't know what happens after this, but right around 3, I'm pretty sure I know what the behavior of this function is. Lastly, I think it's, yeah, lastly, there's the homework cloud in the distance. It's kind of a nice sight. A horizontal asymptote. A horizontal asymptote, behavior as x goes to positive infinity or x goes to negative infinity. This is kind of like the big values. So when x goes to positive infinity, we just think of what happens to y. Well, what values am I thinking of as x goes to positive infinity? I could think of 10, 100, 1,000, 10,000, and so on. And what's going on with the overall function value? Well, bash this into a calculator. I got 30 divided by 14, which is about 2.1-ish. And here, same thing. I get about 2.88 maybe. And as x is going to, 1,000 is a lot less than infinity, but at least it'll give us a pattern here. If I jam in a really big number, then this is going to get, so it appears as x goes to infinity, looks like f at x, or y, I guess, there's no f in this one, y is getting close to 3. And I could even say getting close to 3, but a little bit below. All right. Now notice I should investigate the horizontal asymptote way off on the left as x goes to negative infinity. Same thing, clunking away at my calculator, and I'm just putting in the values of x that I'm choosing, and I'll just do this real quick for you. This one's 5-ish. This one's 3.12. This one is about 3, but a little bit more. And so it appears that as x goes to negative infinity, the y values go to 3 from above. They're bigger. So notice what this tells me. I don't know. Well, I could do the other analysis on this, x and y intercepts, vertical asymptotes. But what this calculation tells me, as x goes to positive infinity, so that means way off here on the right, this is towards x going towards positive infinity, way off on the right, y values are getting close to 3, but from below. So it's telling me this. It's going to get close to 3 from below. Then as x gets close to negative infinity, way off on the left here, negative 10, negative 100, then it's going to get close to 3 from above. This sort of deal. Now, I don't know what's going on in between. I would have to do the other pieces of analysis to figure out that. And of course, part of the goal for us in this chapter is to put all this information together. All right, I'm going to stop there. The homework, actually, you should be able to fly through. There's only a few calculations, graphing calculators for you to check your work if you like, and watch out for those holes.